All right, guys, here we go. 6-1, law of sines. You will be able to use the law of sines for oblique triangles. Find the area of oblique triangles, and you use the law of sines to model and solve real-life problems. Oblique triangles, that's one that doesn't have any right angles, so therefore you can't use Pythagorean theorem. And it shows you here on your paper, right here, it shows you two angles of any side, angle, angle, side, or angle, side, angle, and just all the situations on where you can use the law of sines. So this is the formula, and all you have to remember is, you see how angle A is right here? Opposite angle A is always your little a, and for your sides, and vice versa. B is B, C is C. So there's one for acute, and here's one for obtuse. So let's go ahead and get started, and let's take a look at the one we've got here. And what we've got here is we want to set up and say, okay, let's go ahead and go for A or B first. So we've got 28 over the sine of 29, which is equal to C over the sine of 102. So if we cross multiply, we end up with 28 sine 102 is equal to C sine of 29. Divide by that, and you end up that C is equal to 28 sine of 102 all over the sine of 29. And when you plug that in your calculator, let's see, you should get about 56.49 feet. All right, so let's go for a different one. So now that we've done C, let's go ahead and do A. And for A, all you have to do is figure out what the other angle is. So we know that A is going to be 180 minus 29 minus 102. So therefore, A is equal to 49. So if we want to solve for A now, we would go we would say A is equal to the sine of 49. And I always like to use the one that's given to me. So I'm going to go ahead and use 28 over the sine of 29. Now, cross multiply, and we end up with A sine 29 is equal to 28 sine 49. Divide by the sine of 29. And A is equal to 28 sine 49 all over the sine of 29. So therefore, A is approximately 43.59 feet. Now, if you want, you can go ahead and try the checkpoint, and I'll put the answers up here in just a second. Okay, here's the answers. All right, so for this one, we need to take a look and see what it says. And it says pole tilts towards the sun at an 8 degrees angle from vertical. So here, so that means B is 90 plus 8, so it's 98 degrees. And then we need to figure out, we've got what A is, so can we use that 98 and B? Nope, we need to know what, we need to know what C is. So angle C is going to be 180 minus 43 and minus 98, so therefore it's going to be 39 degrees. All right, now we can set it up. So we want to figure out how tall the pole is, so we need to do A over the sine of 43 is equal to, and remember we're given this one, so 22 over the sine of 39. Now, when we cross multiply, we get A sine 39 is equal to 22 the sine of 43, and then divide sine of 39. So therefore, A is approximately 23.84 feet. Okay, why don't you go ahead and pause and try the checkpoint out, and when you come back, I'll have the answer for you. Okay, the answer is 13, oops, that's not good. Hold on. 13.40 meters. All right, let's cruise to the next one. So now we're going to talk about ambiguous cases where it's side-side angle. So here's where you're looking at where like the side can't actually be there, right there. And that means you have to make sure that A is less than your, that's where A is less than your height. You've got to make sure that A is either greater than or equal to the height. Otherwise, you don't have an angle. And so we're going to consider these triangles here. Again, here we've got A is less than or equal to B. Same situation. You can't have a triangle if that's not there. And then with each one, it tells you how many triangles, how many possible triangles there are. So if A is equal to H, you have one triangle. If A is greater than or equal to B, you have one triangle. But if H is less than A, which is less than B, that means that you can move your A either here or here. So it gives you two triangles. And then if A is greater than B, you've got one. So if we look here, we can see that A is greater than or equal to B. So therefore we have one solution. So let's find that solution. So I'm going to use the law of sines, and I'm going to say that 22 over the sine of 42 is equal to, let's see, let's go for B because we're given that, 12 over the sine of B. All right, so when you cross multiply, you get 22 sine B is equal to 12 sine 42. Therefore, the sine of B is equal to 12 sine 42 all over 22. And to get B by itself, you're going to do the inverse sign. So I'm just going to put it right below. So B is equal to the inverse sign of your whole equation. All right, so when you plug that in your calculator, you find out that B is approximately 21.41 degrees. Okay, so if we have B, that means we can find C, right? So if we find C, we just subtract from 180, and we end up that C is approximately 116.59. And so now we can set that one up. So C over the sine of 116.59 is equal to 22 over the sine of 42. Again, we want to use the information that's given to us just in case we made a mistake. We're going to cross multiply, and when we cross multiply, we got C sine of 42 equals 22 sine of 116.59. So C is equal to 22 sine of 116.59 all over the sine of 42. When we solve this, C ends up being 29.40 inches. Okay, I'm going to go ahead and let you take a pause and give the next checkpoint a go and see if you can get it right. Okay, the answer is B is approximately 12.39 degrees. C is approximately 136.61 degrees. And little c, or the side, is 16.01 inches. All right, let's move on. Okay, so you're going to go ahead and go on to part 2.